So let's continue. Our fifth day of data structures. And today, well, the subject is relatively easy for those who have programmed today. It will be, I think, will seem relatively trivial because we'll be talking about looping constructions, which in C++ are basically very similar to most language you already have used, right? You use Python, you used, what else have you used? What other language have you used besides Python? C.
In school?
Yeah.
Or,
yeah, in general.
JavaScript.
Yeah, but like really briefly.
SQL.
Okay, SQL.
Java.
Java, okay. What else?
We didn't use Java in school.
Some have used Java in school, right?
Because in the CS50 it was like a week.
Of C, right? Week of C. You had
No,
week of
C was like 4 weeks. I think, or something.
Okay, all right. Then you had JavaScript for a week, right?
Yeah, so
yeah, okay. But yeah, if you, of course, you had 4 weeks of C in CS50, right? Then, of course, looping constructions in C++ basically mirror the C constructions, well, with some changes. Okay, what I did is I made a repository for all the code here separately, so this is public. You'll be able to access it. And I'll add it maybe for the class, so it's not all the Replit materials are still there. Do I have a GitHub here? Yeah, I do have it. Let's see, that's the one. And that is yeah, that's it. Okay, so there is a repository. Okay, now again we'll look at the materials, control structures, repetitions, and basically, yeah, there's basically 3 loops. While loop, right? For loop and do while. Again, the do while is maybe a little bit less used, but again, of course, they're all standard looping constructions. How many different loops do you actually need in life? Well, you could get by with just one, right? You could just get by with a while loop, theoretically, right? But for loops are maybe a little bit nicer, right? So now I was trying to find how you can get a link to code space if you have a repository to open a code space based on that repository. Because what I did is I have the link to the code space already. Where is it now? Where is my code space? No, where did it go? No, oh, I forgot now. Where is it? Oh, here you go. Right. So, yeah, I have it here, right? My cuddly space fork, right? With 8 gigs of RAM, right? 2-core processor, right? I can use it, right? Oh wait, no. So I don't want to actually. I want to open not the repository. I want to open it, right? I guess cuddly. Okay, that's it. Yeah. So it will open up the virtual machines. And since this machine, I don't want to worry about. I don't want to bother with setting up the compiler, right? I have a nice little Ubuntu machine here. Maybe not very powerful, but still good enough, right? Let me see. Do I still have my nice extensions? Can I install? Oh yeah, I have my Copilot, right? Well, it's actually, I guess it's reinstalling C++ extension pack. Okay, that's very good, right? Yeah. So you should be able to proceed quite nicely, right? So yeah. Again, the downside of this web-based, of course, is some shortcuts don't work, right? If you're using Visual Studio Code. So again, how many people are using Visual Studio Code for their C++ code? You have, right? Almost everyone. And some people are using C-Line, maybe? One person, yeah. And who is using just a full Visual Studio? Anyone? Yes, that's completely fine too, right? So of course, the full, this is what you used, right? If you actually worked on C++ code for Windows machines, you use Visual Studio for like 25 years, right? It's still, still a golden standard. But of course, these days, we're all so used to this Visual Studio Code that it's easier. Let me see again what is my compiler is. Right, 9.4. It's like pretty old Ubuntu version, 20.0, right? But okay, right? You can see here. But we could of course upgrade, but there's not really. I guess if you want to play around with some of the newer versions of the installer, right? Of the compiler of GCC, right? So, actually, is there C-Lang here? Let's see, I don't think so, right? Actually, there is one. There's C-Lang also, right? C-Lang also for compiling as well. But okay, now we had our main. What did we do on our main, right? We had Fibonacci. There's pre-release version. I don't want to be in a beta tester right now. We could maybe some other time, right? And we did some we did some, we had some magic calls right here, right? Return, we had some functions, right? We return some 0 digits. Let's do some looping, right? So I'll make a new file, loopings, loops, or C++, right? Separately, right? Now, again, so what do I need to include? Probably I/O, right? I/O stream, probably, right? Again, this is provided by the extension, right? By the cheats, not by the AI, right? And of course, again, using namespace, that's probably provided by Copilot. Again, there is some people don't like using this namespace standard because, well, because it sort of hides all the things from standard namespace, right? If you notice, the documentation in C++ does not use it because, well, you lose the prefix because you potentially there might be a conflict with somebody else's function, right? When I use this, right, it's for us lazy programmers. It's a good. I mean, it's for space. They are saying I'm going to use the standard naming, the prefix, right, for things. So int main, right? Okay, it's enough of mom. I'm not going to say hi to mom, right? We'll do some loop, hi loops. Time to start looping, right? All right. And of course now, so question is now how do I compile, right? Because now it's going to try to compile. I don't think this will work, right? Because I have loops, right? The shortcut won't work. I can try, right? Build active file, and it doesn't let me. I don't want to debug it. I actually want to just build it, right? Right. G++, right? I could do it, of course. Yeah. Yeah, builds. So you notice here, right? There's a loops binary, right? Right. And also, of course, it lets you do the debugging run, of course, as well, right? You can do a debug, but I don't want to evaluate expressions. Right? Quit. Control C, right? I see what where is it here? Oh, okay, terminal here. Actually, I'm here, right? So if you see, right, loops. If I do this by manually, G++, right, with all errors, right, and I'll do loops, right, C++, right, output to release, maybe, loop, release, loops, release, right, binary, right, compiled, right, let's compare. Well, what's different between, why is my release so much smaller than loops, right? Remember loops, so this is a debug version, right? So they added a little extra hooks, right, to follow the, for debugging tables, to follow the variables, right, when you do the debugging, right? So here, loops release, right, which is when you boot production, is what you want. It basically doesn't have all this extra craft, right, for developers, and you basically actually have the program, right? So loops, right, okay, time to start looping, right? So historically, again, let's see what the slides say, right? They will say some, break and continue, of course, is useful, right? Right, again, why do we use repetition? Well, because, of course, we don't want to repeat ourselves, right? We kind of, that's what the computers are for, right? So while loop, right? Same, again, comes from the C language, right? But actually, of course, all the other C type language, Java, JavaScript, PHP, C#, Scala, and so on, even Rust, right? Even Rust is, and of course, even Golang too is actually based on C because one of the persons who did Go actually worked on C, and so pretty much almost all languages except Python, right? So while something is true, statement, right? So again, statement can be simple and compound, meaning you put in curly braces. Expression, this book calls decision maker, right? Okay. I haven't seen this often used, but I mean, yeah. Basically, you need some sort of Boolean. Again, remember in C++, just like C, you will have the true C values. If it's non-zero, basically it will keep running, right? So let's do some tricks, right? So let's see if this works. Let's start with while loops. Let's start with a while loop, right? So for while loops, we need a a condition, right? A condition, typically, it will involve a variable that changes, right? Thank you, AI, right? Of course, we'll see it's not always necessary, right? You could have like a constant, right? Like a true, right? While true. We'll see that as well, right? So, classical, of course, example be, yeah. So, int I equals 0, right? While, yeah. Again, basic stuff, right? Right? Really boring stuff, but again, I think basic, again, just a repeat, no, maybe not boring, I would say. This is just a complete, regular day stuff you do, right? But again, yeah, I'm going to do release, right? As you can see, we stop at 9, right? Again, no, maybe we should make it a little bit bigger. Make it bigger. No, Control plus. Yeah, Control plus. Yeah, a little bit bigger, right? So you can see this, right? So no questions on this one, right? Some people, there's no need for semicolon here, right? I mean, if you put semicolon here, it's not going to do anything, right? But of course, you need semicolons here, right? Obviously, you don't need this. So let's see, can we do anything fancy? So first of all, yeah. So what's the downside of this approach, of course, is that we need to do this incrementing by hand, right? We have to do some sort of, we have this condition, right? So this is, of course, not the best use of while loop, right? We would probably want to use what kind of loop? For loop, of course, right? This would be a for loop, yes. Very good. So can we do some tricks? So let's try some weird stuff, right? So let's do this. So we could do this. Let's do another while loop, but we will have a simple I as condition. Right, so while this also happens, right? This is also possible, right? So what I'm doing basically, so will this work, right? And to what extent will it work? What do you think? Will it work? Okay, so at the end, yeah, exactly. How much will I be at the end? What do you think? 0, yeah. Because not -1, 0. Why? Because
check for
non-zero, for non-zero, yeah. It has to be non-zero. Of course, this is slightly dangerous. This is a useful pattern. Slightly dangerous, right? If you mess up, right? This is a stronger condition. I less than 10. This says as long as I is not 0. So as long as I is not 0, the loop will run, right? So again, if you have any questions about this, let me know, but you shouldn't do. All clear, we can check the terminal, it's all 0 now, right? So we had 1, -1 is also possible. But again, philosophically, while loops are best for indeterminate loops where we are not sure how long, right? Because we make maybe some input, maybe something. For example, right? Let's see what will they show us break right now, right? So here's an example, right? Again, nothing too hard, right? So this is the loop. So right. So this is a very common programming pattern, not always needed actually, right? Again, the book calls it sentinel, basically a flag, right? You have some sort of like, you want to quit, right? You put basically you put a flag issue, basically you have a flag basically, right? Approach, yeah. One usage of while loops. Yeah, okay, sure, why not? Let's see. Let's get a number from user, right? Yeah, number, right? Right, okay, oh, well, my loop. And I don't know the loop. This is AI is a little bit more, but no, I don't know. Until, yeah, I think I showed you this before. I think I showed you this, right? Yeah, get digit, right? Look at this approach, right? No, that's not it. No, okay. Here, right. Now, let's get the number from the user until the end. let's get the input. Input from user. If it is not, we will keep asking. So this is like keep asking for number until you're satisfied, right? This has also been used in Python and other places. Right? So put in a number, cin number. We don't have number yet. Int number, right? Int number. So the thing is, right? It's possible people are crazy, not stupid, but people got a very, how should I say, come up with weirdest inputs, right? So you want a number, right? So what do? You put a while loop, right? So while, yes. So this approach, right? And this is a bad approach. I think I could have sworn I showed you this before, right? So instead, this is a bad idea, right? By the way, right? This is a AI knows, it has seen these examples, but this is kind of like, remember, this is not the best way to do it. What do we use? We use limits, right? Include limits. No, a string maybe too, but limits, right? Limits, yeah. On this one, hopefully AI will do it for me, right? Yeah, standard. We want to ignore max. Yeah, this is what you want to do. Numeric limits, stream size, max, right? Until then, right? So basically, this is this flag, right? It's actually a method, right? Right? Yeah. You don't have to check the individual, right? Yeah. It's historical practice, right? There also might be other things that if it's fail, right? Fast error checking. Fast. I like that word, fast, right? So it says only thing is what historical practice. It doesn't say you can't use this, it says you can use it. Maybe there might be some others. We can check some other state flags, right? So you check some other flags, but this is fast, right? Because there's two flags. Bad bit, yeah, you don't have to check the bad bit. There's also a fail bit, but basically this checks both, right? So this is while you're failing, you keep doing it while you're failing, right? You keep running this until you fail. So this is, the thing is, remember about the input, right? You need to clear it, right? You need to, if there is a fail, you need to reset state fail, right? So if you fail, you need to clear the fail. That's where you might fail in your failing, right? So, yeah. Okay. So then you have to ignore, right? You need to then you need to, yeah. Then you ignore the buffer because it's all messed up. Again, it's possible, of course. Sometimes you might need the buffer, right? And then you could use ignore, etc., etc., etc. Right. Buffer. And again, buffer, what's buffer basically? It's like a stream of, it's an abstraction, right, of stream of bytes coming in, right, from your console in this case, right? It could be also from network or a file stream, but of course in this case it's console, right? Please enter a number, right? And this will work, right? So, again, so it is possible that the user inputs non-number here, right? So in this case, we don't know when the user will get smart and figure out what we want from them, right? Let's run this. I'm gonna loop the release and enter a number. Now remember, all this, right? No, RBS, no. Now 3.14, right? Okay, it lets you do it because integer, right? So the thing is now, so what happened to point 14? Well, it wasn't a buffer, right? It was not a fail. So that's the thing, actually. Technically, it was still in buffer, but the parser, this console input parser, it knew that this tree was good enough for it, right? And it used that as an integer. Again, depending on your needs, right? Maybe you need also the 0.14, and of course you could use a double here, right? Double precision for floats, or you could also use it, try to process this afterwards separately. Okay, now, so this is one use of while loops. But I wanted to, I'm gonna call this. I'll put this. This will be a good function, right? Make a function for right. But now also it is somewhat common to use sentinel values flags to stop a loop, right? My flag, right? So we'll do bool stop, please, right? It's false, right? And I'll do true. No, sorry, let's do stop, please, false. Let's think about it now. Let's think. Well, okay, yeah. Right. So, and this is where you get into reverse, right? And then there's discussion. Do you want to have a positive affirmative flag or negative flag? This is a negative flag, right? Stop, please. So, if stop, please is true, you want to stop, right? So you have to, what we are doing here, what's happening here, right? This exclam, what's happening? What is that operation?
Not.
Negation, yeah, we're reversing it, right? Back and forth, right? So in this case, we are not, so not false is true, right? So, while not stopping, please, right? So, we could of course rewrite, yeah, do you want to stop or exit, right? We set, if answer is yes, stop, please. This is not the only way to do it, of course, right? Right? This is one way, right? So hopefully you can see this idea, right? Somewhat common, right? Again, it's not the only way, right? Sometimes this is, if you put too many flags, it might be too many flags might make too many flags might make, yeah, exactly what I want to say, right? Yeah. Personally, I try to avoid it as much as possible. Again, it cannot be 100%, but it's if you have too many flags, right? Sometimes it's a way. It might be flags. Flags might be a way to get some code working. Yeah, that's basic. Okay, it's a judgment call. It is a judgment call. Yeah. Okay. Right. But you're all clear on this code, right?
Yes.
Okay. Or it could also be, of course, yeah. We could have used, of course, we could have used continue, please. Yeah. Set to true, right? Yeah. Continue. Okay. Yeah. All right. Now, I'll close this example, right? Loops. Now, what else do you want to see about while loops? What does the book say? Book is pretty much, I mean, this is all people learning telephone digits, uppercase with corresponding telephone digit. Okay. So again, you see there's a flag, is found, right? They're using camel case, right? While it's not found. So while it is not found, we reverse, right? Is found true. So you'll keep looking for something, basically, right? You keep looking for something. If you find it, right? You set the flag and you update. Okay, yeah, you can use that. Right. Random function, generate random number, right? And what do we want to do? Now a number guessing game. Yes, we could do that. We could make a number guessing game, right? Sure. Right? Pretty easy game. We'll use cstd_lib to get the general number. Again, of course, standard header, right? So, but we want from 0 to 100, right? And well, again, if you remember your Python, right, libraries, you don't have to do that much work, right? But random in a cstd library, let's check, right? We want to do a simple random guessing game. Remember Steve Ballmer, right? That's Steve Ballmer's challenge, right? You had that how many questions should you be given, how much money to bet on the answer, right? You need, for 100 numbers, you need about, well, less than six or seven questions. Well, at most 7 questions, right? To the
Yes.
7th 128, right? Okay, right. But the issue here is if you want to do this in C++, I believe does not have a nice library for this. Let's take a look actually this, right? So we will use this. Let's make a random guessing game. Guessing game. C++, right? Include let's make a random guessing game where user has to guess number between 100, right? Include few guesses. We also want to keep track of guesses. Okay. Yeah. So function get number. Okay. First of all, we need some. First, let's start. Let's import libraries. So since I'm lazy, as you can see, I'm very lazy. Let's import the libraries. We need the libraries first. Right? Include IOStream. We'll need also CSDD, like the book says, and like Copilot agrees with the book. Very good. Right? Oh, let's see. So now we can make the get. Now. Yeah, let's use them. Of course, right? That's because we're lazy. Now we need. Let's write the function to get the random number between 1 and 10. Well, between start and end, right? Yeah, get random, start end, right? So random. Let's cover this. Yeah, rand max, right? What the heck is this thing here? Okay. Yeah. So rand max. So what's rand max? I believe it's probably they said 32,000 something, right? Yeah. So this is like half of the 16-bit integer, right? Yeah. So 2 to the 15th, right? Yeah. Okay, right. So you have to again. So this shows how in C++ you have to do some work yourself. And if you think about so end minus start plus 1, right? So this would give us what start is 1. Question is, will we get? Let's see. This is correct. Oh, yeah, plus start. Okay, yeah, very good. This is just general formula. Yeah. So you want. First of all, how many different numbers do you want? You want, so 100 minus 1 is 99, plus 1 is 100, right? Right? This is general formula. This is useful for this. Next is a general formula. Yeah. Yeah. Inclusive. Right? You want both. This is just like how Python, if you have to, this is possibly how Python implements this random, right? You want start and you want to include both, right? So, again, what could I do if I say, okay, this is great? Usually, you could say if this is a longer function, we could refactor this and put it at the end of the main, right? For now, we just put it here. So, let's do the game. Now we can do the main function. So int main, right? Int main. Come on, let's do it. Copilot, do your magic. I'm lazy. Yes. Right. Okay. Yeah. So this is for now. This is time. Current time. Put in timer. Pointer. Yes. So C. So we'll have a game, right? So we get number, right? So this is of course this could be broken. This of course I think it's milliseconds, right? It says C time library. Let's see. No, it's not. It's saying it's okay, right? I believe extension will pick up. We'll see. When we compile, we'll see. Okay. So now number. Now let's get the number. Welcome to the game. You need to guess number between 1 and 100. Good luck. Let's declare a variable. Let's guess, right? Also, right. You took guesses, right? So while true, notice something here, right? What we're using a forever loop. So, where do you usually use a forever loop, infinite loop?
we have to wait for constant user
Yeah,
interaction.
but for example, it's extremely like most games, most pretty much all applications. Well, the whole biggest loop is going to be a infinite loop, right? And then you check for some condition to break. You might have this condition here instead of the true instead in the flag, but here, how are we going to finish? We use break. So this break exits the loop, right? The loop, the closest loop, right? Inner loop, innermost loop, right? In this case, here we just have one loop. Yeah, okay. Hopefully that makes sense. Now, is the program pretty easy, right? Enter your guess, and also we are actually for integer, right? So, this program is going to break if I put Valdis, right? It's going to break RBS. It's going to break. So you probably want to fix it up a little bit, right? Okay. Thanks for playing. So this is just a scaffolding, just a very rough game in progress. We'll fix stuff. We'll fix stuff, right? Pretty easy. So let's run it. Guessing game. So G++, guessing. Let's see. Do you think it's going to compile? I don't know. Guess. Oh, compiled in first run. Okay. Right? How big is it actually? Where's my game? Pretty small, 17K. Right? Not bad at all. Right? The extra libraries, we include this random library, but it didn't really cost us much extra. So let's run it. Let's see if it works. First of all, will I be able to beat it? Okay, so I'll enter 5. Too low. That's bad. That's bad guess, of course, right? I would lose Steve Ballmer's money, right? I would pay him, right? I should of course put what 50, right? Too low. Okay, so how much should I put? 75, exactly. Too low. So now 88. Let's do 88 or 87, right? Too low. That's suspicious. Maybe it's like 5 million, and there's a bug in my code, right? No, let's see.
99.
Yeah, that's scary. No, okay. I'll put 95. 94 probably better. Okay, 95. Yeah, this looks bad. This smells either too bad or maybe it's a big number. Let's see. Okay, so maybe
99.
You think 99?
Yes.
Yeah, it's bad. This is bad. No, it worked. It was 100. That's a little suspicious. It's like, what's up with that? Like 100, right? Well, what are the odds of it? 1 to the 100, right? Those are the odds, right? So let's run it again. See what happens. Yeah, that's what I'm saying. This looks suspicious. Too high. Oh, fool. Okay.
Just one.
Yeah, maybe it's not 1. Too low. What?
Too low.
Oh yeah, that's correct. I don't know. Fool. See? 25, too low, so it's 37. Yeah, so this looks like okay. 44. 41, too low. 42 or 43? Which one? 42. Yes, the answer to everything. 42. Okay, so the game works. Well, it looks okay, but the problem, of course, is if I do this and I put Valdis, right? Oh yeah, look at this, what happened. Yeah, it got to the forever loop and it actually started calculating too low, too far. This is actually, let's see what happened actually here. It's forever loop, right? We don't have a break. And I believe the buffer broke and basically need to check actually, right? So looks like we never get to break condition, right? So we would probably want to have the function for checking, asking for integers, right? Yeah. So let's make a function. Let's make a helper function that asks for an integer, right? So, yeah, get integer. I need, of course, string here, right? Good string. right? Not C time. Oh, C time actually, apparently I don't need it. It's like apparently part of it. Right? String, right? On message, right? While true. So I keep asking, get number, fail. On numeric limits also. You see, I have to add lots of extra work now. Include limits. So even simple things, right? You need to do some extra work, or maybe you have your prepared functions, right? And then it's fine. Okay, now, right? Let's do this, right? So welcome to the guessing game. Guesses on guess on. Basically, what we'll do is here. We will fix this part here with the function. So guess equals get integer. Please enter your guess, right? Numeric guess, your numeric guess, right? So this is of course. So what do we have now? We have loop within loop, right? And we have loop within loop. We'll take a break in 3 minutes. Or wait, what's our time schedule? Let's see. We have like more time. Let's see. Let's add some few more things. Actually, maybe let's like 5 more minutes. So let's finish this game. So now I have get integer, right? That's better. Right? Will it compile? I think so. Will it work? So 50, too high, that's me 35, too low, 38, too low, again 42? No, too high, so 40. Thank you, 5 guesses. Okay, well I didn't try to break, let's try to power this. Alright, RBS, okay, very good. So I had final do 50 and so on. Oh, 1 guess, okay, great, I got $5 from Steve Ballmer. Okay, I got on first try. Now, so things, how you, well, a couple things as far as C++ goes, right? First of all, we mentioned this, like, I mean, I could of course just minimize this, right, like this, right? But what we could do is, we could move these to the end of it, right? Right, so I will declare it, right? So, I would say, okay, I want, so int, get random, int start, int end, right? And I will do this, right? And now I can move it. Well, of course I could leave it here, which would be stupid, but yeah, I could, right? Right? So you guys see, so you know, you understand this idea of C++,
yes.
Right? Yeah, okay, no big deal, right? And I could move it back. Of course, another thing, of course, is you could eventually have it in another file, right? You get linking, right? You have to link, right? So, get random, and also we'll do the same thing for get integer. Let's do this, right? So int get integer. Casting that. Okay, right. Now, of course, my code, all my extra unneeded strings are in the bottom, right? So my main is the first function. Again, that's kind of nice ideal. Sometimes you're lazy, you don't do it, right? Also, maybe you want to have this help fixed. You want to helper functions, right? And this would be nice, right? And again, because I'm not writing it, right? Actually, this is also not correct, right? I'm just declaring it. All right. So ideas now. How could we improve this tiny thing? What I don't like about this, of course, is this part here, right? All right. What I don't like are these. This smells like magic numbers, right? As far as code smells like 100, yeah, very fixed. So how could we change this? You could have some constants, right? Have it separately somewhere, right? So that would be my first advice. If you have something like this, maybe you never need to change it. That's okay. Then you won't really lose much time, right? But declare helper functions. Declare helper functions. We'll define them later. Okay. Now let's define some useful constants. Yeah. Okay. Min, max. Capitals are not capital letters are often used for constants. Not required, not absolutely required. Not always, not required, but convenient, not convenient. Okay, so it's not a, right? In min-max, again, min-max, min is kind of max, right? So what I would do is here, right? And again, by the way, so min, I would probably even do min number. Min and max is kind of a little bit dangerous because it's too generic. I would say min number, I'll do this min num, I will do this min num, max num, right? A little bit more descriptive, right? So what do I do here? I replace min num, and as far as computer speed, compiler is gonna replace these numbers, right? It's just pure replacement. Well, actually, it's not a macro, but it's actually a constant. Still, compiler is not gonna complain about this. But what we gain, of course, we gain now. If sometime in the future your boss comes, hey, this game is too easy, right? Let's make it harder, right? So what do you do then? You just come here and you change these constants, right?
Yes.
And that's it, right? And you save yourself a lot of time. And you can say, okay, I spent four hours in this task for a full day, right? Right, trying to fix it, right? No, you don't say that. No, but you, well, at least you save yourself some time. You can maybe, clean up some extra code. There's some time for other things. No. Now, everything is good. What I would also like, we have like 2 minutes, what I would like to ask, of course, is most guesses, right? We want to lose as well, right? What kind of game is fun if you can play, forever, right? So let's add that. Let's add max guesses. So, 10, that's pretty lenient, okay. All right, 7, let's make lean, let's do it hard, right? Let's make it, 6 would be hard, right? 6 would be, yeah, make it, this perfect play, sufficient, yeah. 6, oh, yeah, it's fun, okay, 6.64, I think that's about right. Okay, so how do we add this max guess? Well, we have guesses, right? We have a variable now, so what we do is, well, we could check here, right? Or where the guess is plus plus, we could check if guesses, right? Yeah. Okay, so let's see if this is correct. We start with 0. Oh yeah, it is correct. So we start with 0. So 0, 1, 2, 3, 4, 5, 6. And I would say, okay, so I would say again, equality of course is correct, but I would say more equal, right? I'm a little bit strict equality. It's easier to get wrong. Well, in a way, it's more. Maybe you have to be completely correct then, right? So more equal. So I think this is going to be enough for today's game, right? Let's try this now. Let's compile it. G++. Well, guess. Okay. No. When I'm going to get any errors? Not getting any errors. Okay. Or not even any warning. I guess it's too simple. So guess. So I'll do first. I'll do garbage. No problem. So I have to guess. 50. Let's try losing. 60. Way too low. 70. 80. 90. Too high. Do you think I have like 4 guesses left? 85. Too high. I should be able to. I should lose this, right? I won in 7 guesses. Okay, let me try losing, and then we can then I'll let you guys go. So I'll do 1, 2, 3, 4, 5, 6, 7. Yeah, a number ready is 7. And not my guessing strategy was suboptimal. Okay, so this part here it should be now. Let's see what I'm gonna commit to this. First of all, I don't really want to commit the binaries, right? Binaries really should not be committed generally unless you are for release, right? Right. So I will add this, add the git ignore, tasks. Technically, what is in the tasks? What is in the tasks? Oh, it's just some things. Oh, it's a build. Okay, I can leave that in. Guessing game loops. Guess. on this one here too. I think it can all. Yeah, theoretically it would run on some Ubuntu 20 machine, but you don't really want the binary, so it's going to recompile this stuff. So, guessing game with loops. Yes, always. Yeah, again, because synchronize. And now, if you want to see what we did in class today in the first half, you can see it here. Where is it? This one here? Yeah. Let's take a look. Where is it? Why is it not there? Oh. Uh-oh. I don't like that.
Did you put
No.
changes?
Yeah, the image, I believe. I need to pull. Oh, this is gonna be a pain now. Now it's gonna be a pain. So during the break, I'll fix it. I might have to do a reset, maybe a rebase. Things I really don't like doing. Let's take a look. Log. Yeah, head's not symbolic. Let's see what it says here. Created failed to execute git config. Oh, let's look at the first message. Yeah. Failed to execute git. What's up with that?
Try
Yeah.
pushing it from the terminal instead of
Yeah,
interactive.
would be. But first of all, git status. Let's see what's happening. Nothing. Okay. So git pull. Can I do that? Oh. Okay. I can't. Well, the problem is I can't. There's some chip. It's because I added. You know, the thing is, I added. I'll show you the example. Problem is, it should not be a conflict. I added this Riga Business School logo. This part here, right? It has nothing to do with the code you are writing, right? But so I need to repop this git space, the code space. Unfortunately, the virtual machine did not. I need. Okay, the version. There shouldn't be any conflict, right? Right. So this one here, I believe, merge or rebase. I think rebase too, right? Which one? If we start with rebase, so merge, right? Merge would be okay.
Yeah.
Come on, let's do it. Control Shift F. Come on, I wanted to copy. See, that's the problem is.
To allow your.
Yeah, because it's virtual machine. Okay, now Control Z. Yeah, okay, let's try this. Let's try now. Git pull. Whew, that worked. That worked. I don't need merge.
Colon Q, I think. to access.
Colon Q. Oh, not here.
Oh,
Here.
wait, this is a text. No, this is just text file.
Yeah, it's a merge message, right? Okay. Yeah, I mean there shouldn't be really anything. Okay, so now, yeah, now it should work. Guessing game. Let's hope so. Push, pull, and pull. Okay, let's do it. Let's do it. Come on, please do it. No, I don't want to know, but I could, of course, right? Let's see now. Now it should be okay. Yeah, let's say. So now let's check code. I'll give you okay. So we have the guessing game, C++, right?
Yes.
All right, great. Okay, so let's take 15-minute break.